In this lesson, we're going to bring back the concept of the mole and talk about molar concentrations. So we recall the concept of concentration, and this is the amount of solute that is dissolved in a specific amount of solution. And in our last lesson, we talked about concentration as a percentage concentration or parts per million, parts per billion. We'll remind you also that a concentrated solution contains more solute and a dilute solution will contain a smaller amount of solute. And so the amount of solution is the same, but the amount of particles, solute particles, is either more concentrated or less concentrated. When we talk about molar concentration, we are now going to talk about the solute in terms of a mole value. And we're still taking solute divided by solution, just like we did in the previous lessons, but these units will change. So if you have moles of solute over volume of solution, we actually will measure the volume now in liters rather than milliliters, because molar concentration is most often used for solutions used in industry. So where you're making larger amounts of solutions. So in a lab setting, in a factory setting. And so they use the unit of liters instead, which is just a bigger volume unit. Molar concentration has the symbol, two symbols. So the symbol for it is a capital M. Okay, so just a single capital M would represent molar concentration, or you can use square brackets around the formula of your substance. So for example, if I was solving for a molar concentration of copper 2 chloride, let's say, I would write it like this. Okay, so I would write the formula of copper 2 chloride, that's a C and an L, and I would put square brackets around there. The square brackets tells anybody who understands a bit about chemistry that we are talking about a molar concentration. When we talk about the units of molar concentration, because we're taking moles and we're dividing it by liters in the actual mathematical calculation, that becomes our unit. So we would have units of moles per liter, because that's what per means, right? That we've divided it out. Or we will sometimes use a capital M for that unit. Okay, I use both of them interchangeably. You need to be aware of both versions for it. And sometimes, lastly, instead of calling it molar concentration, we will sometimes call it molarity. Okay, so as you see, different ways of representing the same idea or the same unit can be had. Let's do an example with molar concentration and review our mole concept. So a saline solution, which is salt, contains 0.90 grams of sodium chloride dissolved in 100 milliliters of solution. What is the molar concentration? So we can set this up and we can say we're going to need two steps here. We know that for molar concentration, capital M is going to be equal to the moles of your solute divided by your volume. And when we set that up, I always put a capital L beside my V to remind me I need liters. Okay, so I'm going to need mole value here and I need my volume. Well, I have my volume. It's not in liters, but we can convert it. And I need a mole value and I don't have it, but I have mass and we can easily calculate the number of moles. So let's start there and calculate the moles of sodium chloride. So we're going to take our good old mass over molar mass formula. We have 0.90 grams, and the molar mass of sodium chloride can be calculated to 58.44 grams per mole. We get a mole value of 0.01540 moles. And we won't chop or round yet because this is not the final answer. So step 2 would be to calculate the molar concentration. So remember, you can use, for molar concentration, you can use a capital M, you can use square brackets, right, around sodium chloride. Let's do that. Okay, let's get you used to this because you will see this quite often. and then we set it up, moles over our volume in liters. So our mole value is 0.01540 mole, and then we divide by volume, but I need it in liters. So to convert from milliliters to liters, we need to divide by 1,000. Okay, so make sure that you know that. If I take 100 and divide it by 1,000, I get 0.100 liters. When I divide those two values out and round to 2 sig figs, I get an answer of 0.15. And again, you can use two different units here. You can say moles per liter, or you could say 0.15 molar. That's how we read it if we use capital M as the unit. So you have options there. It doesn't matter to me which unit you pick. Let's do one more example with molar concentration. And in this example, it's asking us for the mass of solute that would be present in 65 mils of calcium sulfate, and they tell us the molar concentration. So it's up to you. You can write things down off to the side if you like that. So maybe you want to figure out, the mass. You know that the volume is 65 mils. We might as well convert right now. Why don't we do that? Into liters. So again, we're going to divide by 1,000, which is going to give us 0.065 liters. And then we know the molar concentration. Watch your M's, right? So that you know this is a capital M rather than a lowercase. My pen is not great on this screen. So 0.0153 moles per liter. So if I need to solve for a mass, I'm going to have to go and solve for moles initially, and then convert over to mass. So just recall, right, that we have three mole formulas now. Here's one, and then we have this one for molar concentration. So I want to solve for moles. That way I can plug it in over here and rearrange for the mass of my substance. So let's solve for the mass, or the moles, of calcium sulfate. So again, knowing nomenclature is very important, particularly for molar mass. To solve this, I'm going to take the molar concentration times my volume. So I'm going to say 0.0153 molar times 0.065 liters. When I calculate that, I get a mole value of 0.0009945 mole. And then we'll take that mole value and we'll convert it to a mass of calcium sulfate. And we'll take moles times the molar mass. So 0.0009945 mole. And then calculate that molar mass of calcium sulfate. I got 136.14 grams per mole. And then I get an answer of 0.14 grams, rounded to two significant figures. So again, just bringing in a new mole formula, but still going back and using those original mole formulas that we learned back in Unit 3.